Welcome to Measurement Design and Statistics 2, Week 5. This week, we're going to continue to push on increasing the complexity of our ANOVA designs. We'll focus on 3 extensions: simple repeated measures, the 3-way independent, and then the mixed between within design. Let's start with a simple repeated measures design. We'll look at weight scores of kids before and after a year in a lifestyle program with no control group. Analytically, what should happen is that the program will compute a difference score for each child, and the standard error of those differences will be used to determine whether change is significant. Because we're only looking at differences, we're focused on within-person changes. We've thrown away variance concerned with individual differences, producing a smaller error term and a more powerful test. In addition to this power benefit of repeated measures, you may need fewer participants in a repeated measures study simply because the same people are experiencing multiple conditions. We've seen figures like this before, but basically, when we focus only on within-person changes, we throw away between-person variability, and our analysis distills down to explained versus unexplained variance in within-person change. Let's use a basic example with no control group and just repeated measures. We have 10 children that enter our lifestyle program. Weight in pounds is assessed before the program and again 6 and 12 months after starting. This is a 3-leveled repeated measures factor. If I had just 2 levels, we wouldn't have to do an ANOVA because we could just do a paired samples t-test. This has 3 levels, so we have to look at what happens at baseline to 6 months to 12 months. Going across the rows, you see each person's weight at 3 points of measurement. At the bottom, you see that on average, the sample lost about 5 pounds between the first and second measurement and another 3 pounds by the third assessment. This looks like there's systematic weight loss over the 12-month period. And because we have 3 observations on each person, you can also see that there are stable between-person differences. Person 9 on average is the heaviest at 170 pounds, and person 1 is on average the lightest at 123. These are individual differences in weight that have nothing to do with weight loss. That is a between-person variability that we're going to take out of the error term. Then there is within-person variability. The first person lost about 11 pounds, the second person about 8 pounds, the third person about 13 pounds, and so on. People who have more change have more within-person variability. Person 3 lost the most weight, 13 pounds, and thus has the biggest within-person variability, 6.5. Person 10 lost the least weight, 5 pounds, and has the smallest variability, 2.6. Within-person variability is actually a good measure of the amount of change over 12 months. Our data set looks different. We have 3 columns which represent the DV measured at each occasion. You'll see that this means we have to tell SPSS that we want to combine those columns into a single DV in the repeated measures program. Analyze general linear model repeated, and this new window opens. In it, we're going to have to name our repeated measures factor. I'm going to call it occasion, and tell the program how many levels of occasion we have. 3. And there you go, an occasion factor with 3 levels. We'll mostly always skip this lower half of the box, which is almost always unnecessary. The program asks us what columns will make up the 3 levels of the occasion factor with a question mark. And we drag over the 3 occasions in order to provide that information. In this completely within design, there is no between subjects factor. As of version 25, SPSS allows error bars on the profile plots, which is great. Now you can really visualize your trend. With only one IB, it goes on the horizontal axis. If your main effective occasion is significant, you're going to want to see which occasions differ from others, probably via post-hocs. In repeated measures, though, the post-hocs box is grayed out. Instead, you go to EM means, drag over your repeated measures factor in display means, and check compare main effects. There, I drag down the Bonferroni post hoc. In the Options box, you'll select your other output of interest.